Given triangle DEF, state the following ratios in terms of side lengths D, E, and F. Okay, so I'm working with angle F for all these trig ratios. Here's angle F. So lowercase f is opposite to angle F. Lowercase e is adjacent to angle F. And D is the hypotenuse. All right, so cosine, what's the ratio for cosine? Adjacent over hypotenuse. So it's E over D. What is tangent? Tangent is opposite over adjacent. And what is sine? Sine is opposite over hypotenuse. That's all there is to it. We're done. All right, given ABC shown, express the sine, cosine, and tangent of angle B as reduced fractions. Here's angle B. All right, so relative to angle B, this is the opposite, this is the adjacent, this is the hypotenuse. So sine of B is equal to opposite, which is 15, over hypotenuse, which is 39. You could divide both of these by 3. So we have 5 over 13. Okay. For cosine, I have adjacent over hypotenuse. I can divide these by 3. Get 12 over 13. So cosine of B is 12 over 13. And then for the next one, I have tangent of B is equal to opposite over adjacent. So I end up with, divide by 3 again, I get 5 over 12. So tangent of B is 5 over 12. That's all there is to that. Done. For number 3, an altitude of an equilateral triangle is 18 units. What is the perimeter of the equilateral triangle? Okay. I have an equilateral. That's not equilateral. That's still a little more straight. All right, equilateral triangle. It's a little better. Okay, equilateral triangle. What's the measure of all the angles? Well, I know they're all the same. So I take 180 and I divide by 3. I get 60 degrees. It says the altitude is 18. So go straight down. Altitude's 18. It forms a right angle with the base. Okay, so now I'm looking at a 30, 60, 90 triangle now. This is the short leg. This is the long leg. All right. So I could do this. There's different ways to explain this, but I'm going to use the most fundamental terms. I'm going to take the short leg, which is x. I'm going to multiply it by square root of 3, and that will give me the long leg, which is 18. All right. Divide by square root of 3. All right, so now I have to rationalize the denominator. And I get 18 square root of 3 over 3, which is 6 square root of 3. All right, so this length right here is 6 square root of 3. All right, if I want the hypotenuse, you just simply multiply it by 2. So that's 12 square root of 3. All right, and I want to find the perimeter. So it's 12 square root of 3 all around. So the perimeter will be equal to 3 times 12 square root of 3, which is 36 square root of 3. Or you could do 12 square root of 3 plus 12 square root of 3 plus 12 square root of 3, which is 36 square root of 3. Either way, you get the same result. All right, done. And we'll say units here. All right, what is the altitude of an equilateral triangle with a perimeter of 30 units? All right, here's my equilateral triangle. Okay, the perimeter is 30 units. So if the perimeter is 30 units, I divide that by 3, and I get the length of each side. They want to know what the altitude is, so I'll draw the altitude straight down. This triangle could have been drawn a little better. Okay, so I know all these angles here are the same, and they all measure 60. All right, so that's 30 there. All right, now this length here is 5. And it's the short leg to the 30, 60, 90 triangle. So what do you do to the short leg to get the long leg? You multiply it by square root of 3. And that's your height. So the height is 5 square root of 3, or your altitude is 5 square root of 3. And we'll use units. All right, in the diagram, xy is equal to 8 square root of 3. All right, find the length of xz. Okay. Now this is a 45, 45, 90 triangle. All right, so I know this is 8 square root of 3 as well. Now what do you do to the leg of a 45, 45, 90 to get the hypotenuse? You multiply it by the square root of 2. Now what's the square root of 3 times the square root of 2? That's the square root of 6, and you can't simplify that. So xz is equal to 8 square root of 6. Done. All right, in the diagram, AC is equal to 20. Find BC. AC is equal to 20. All right, so if you want to find BC, how are you going to do that? Well, this is an isosceles right triangle. If it's isosceles, I know these base angles are the same, and they both must measure 45 degrees. All right, so I have a 45, 45, 90. What do you do to the leg to get the hypotenuse? You multiply by square root of 2, and that gives you the hypotenuse. So now I'm just going to divide by square root of 2. I need to rationalize the denominator. So I get 20 square root of 2 over 2, which is 10 square root of 2. So BC is equal to 10 square root of 2. Done. In triangle ABC, measurement angle A is 40 and B is 67. Name the longest side of this triangle. All right, always draw a diagram whenever you're not given one. All right, so A is 40 degrees. B is 67 degrees. All right, let's figure out C. So I have 40 plus 67 plus measurement angle C is equal to 180. I have 107 plus measurement angle C is equal to 180. Subtract 107. Measurement angle C is equal to 73 degrees. All right, now it's asking for the longest side. Now the longest side is opposite to the largest angle. What's the largest angle? C. So go across from it. This has to be the largest side, AB. Or segment AB. Done. All right, the teacher sketches the triangle Joy. If you haven't seen the movie Joy, check that movie out. Great film. Okay, so you have a triangle J-O-Y. All right, and J is 2x plus 11. This is 2x plus 11. This is 4x plus 9. This is x plus 27. All right, I know all of these add up to 180. So I'm going to have 2x plus 11 plus 4x plus 9 plus x plus 27 equals 180. Add like terms. I have 7x plus 47 equals 180. Subtract 47. 7x is equal to 133. Divide by 7. And I get x is equal to 19. All right. If I plug 19 in, I get 2 times 19 plus 11. Here I get 4 times 19 plus 9. Here I get 19 plus 27. All right, so I end up with these calculations. And let's see, J will be 49 degrees. This is 49 degrees. O is 85 degrees. And Y is 46 degrees. All right, so she then asks her students which side of the triangle is the shortest. All right, which side is the shortest? This is the smallest angle, so opposite to that, it's going to be JO. All right, still answers JY. Which student is correct? Enrique said JO, so Enrique is correct. Your answer is C. Done. All right, while flying my kite yesterday, I managed to get the kite 300 feet above the ground. 300 feet above the ground. At this height, the string made a 35-degree angle with the ground. 35-degree angle with the ground. About how much string had I let out? All right, so we have a right triangle here. Here's my acute angle. The string here, that would be your hypotenuse to the right triangle. So I will use the sine ratio. Sine of 35 degrees is equal to opposite, which is 300, over h. And I'll call that x. So now I multiply by x on both sides. I have x sine of 35 degrees is equal to 300. Divide by sine of 35 degrees. And x is equal to what? Approximately 523.0 feet. Done. All right, when I went kite flying the other day, I managed to let out an entire roll of string, 400 feet. All right, so this is you, you're standing there, you got the kite string. All right, there's your kite. And you let out 400 feet of string. Formed a 40-degree angle at the ground. And the kite was about how high? Okay, so you're not really taking into account the person's height, but it's just an approximation in this problem. They would have to give you more information if you wanted to figure out everything involving those details. All right, so we have 40 degrees. I need to figure out the height, or call it lowercase h. So I have sine of 40 degrees is equal to opposite, which is h, over 400. Multiply by 400 on both sides. H is equal to 257.1. Round it to the nearest tenth. Okay, and it's going to be feet. Done. All right, in the figure shown, measurement angle T is equal to measurement angle V. All right, they're telling you these are the same. And E is the midpoint. All right, if E is the midpoint, then you know that these lengths are the same. What congruent statement would prove TER is congruent to VEC? Well, I know these are the same because they're vertical angles. So how would I show that TER, this triangle here, is congruent to VEC? We have ASA. ASA. Done. All right, in the figure shown, IN is equal to CK. All right, they're the same. IK is parallel to NC. IK is parallel to NC. All right, what congruent statement would prove that K and I is congruent to NKC? NKC. All right. Well, these two lines are parallel. So I know these are alternate interior angles. And then we have the reflexive property here. So I have no, it's not ASS, ASS, and that's a bad word, it's not allowed. Okay. And the key says it's B, but I don't agree with the key. There's no other information you could come up with. So I would say the answer is E. Maybe I'll come back to this one. Maybe there's just something I'm not seeing right now. All right, moving on to the next problem. Or the key's wrong. All right, in the figure shown, measurement angle C is equal to measurement angle W. So these are the same. And CB is equal to WB. What congruent statement would prove CBN? CBN is congruent to WBA. CBN is congruent to WBA. Well, check this out. I have these vertical angles right here. So then we have ASA, ASA. There's our shortcut there. Done. All right, in the figure shown, measurement angle F is equal to measurement angle U. And FL is equal to UL. What congruent statement would prove LOF is congruent to LOU? And I have a reflexive property here. And that's all the information I could extract. All right, so I have ASS, that's a bad word, not allowed. All right, so these are not necessarily congruent. All right, in the diagram, WE is parallel to OT. Okay, these are parallel lines. All right, IUO is 50. IUO, this is 50 degrees right here. And UPE, this is 120 degrees right here. What is the measure of IUP? IUP, okay. Well, if this is 120 here, this has to be 60, because these angles here are consecutive interior. They have to add up to 180. And then all three of these angles combined here have to add up to 180 because they form a straight line. So I have 50 plus measurement of angle IUP plus 60 is equal to 180. So I have 110 plus measurement of angle IUP is equal to 180. Subtract 110. Measurement of angle IUP is equal to 70. Done. All right, in the diagram, measurement angle WIU is 122. All right, what does the measure of IUO need to be to make WE parallel to OT? IUO, what does that have to be? All right, so in order for these lines to be parallel, these two angles have to add up to 180 degrees. So you just take 180 and subtract 122, and we have 58. So only if this is 58 degrees will these two lines here be parallel. So your answer is 58 degrees. Done. All right, given BD bisects ABC. All right, let's see here. BD bisects ABC. I'm going to draw this angle. All right. A, B, C. BD bisects the angle, and I have BD here. It bisects it, so these are the same measurement. ABD is 2x minus 15. Then I have CBD. CBD, this is x plus 35. What is the measure of ABC? Okay, so I know that 2x minus 15 will be equal to x plus 35. Subtract x. Have x minus 15 is equal to 35. Add 15. And x is equal to 50. Alright, done with that. So I take this and I plug it back in. So I get 2 times 50 minus 15, which is 100 minus 15, which is 85. I know that both of these angle measures then are 85 degrees. Or if I add them up together, I get the measurement of angle ABC, which is 170 degrees. Done. All right, in the diagram, SU is the angle bisector of TSV. All right, so I know these angles have the same measurement. All right, measure angle 1 is 3x plus 7. Measure angle 3 is x plus 3. What is the value of x if RSV is 82? So if 1 is 3x plus 7, and they say 3 is x plus 3, 2 is also x plus 3, I know that all these together they have to add up to this whole thing, which is 82. So I have all these combined, which is 5x plus 13 is equal to 82. Subtract 13, and I get 5x is equal to 69, divide by 5, and x is equal to 69 over 5, which is also equal to 13.8. All right, that's all there is to that. We're done. All right, the following sets of numbers indicate the lengths of the sides of a triangle. Determine whether the triangle is acute, obtuse, right, or impossible. All right, to figure out what type of triangle we're working with, we use a variation of the Pythagorean theorem. All right, we don't know what the symbol is. We have to figure out the symbol. All right, A and B are your smaller lengths, so 12 and 14. So 12 squared plus 14 squared is something to 19 squared. So I have 144 plus 196 is something to 19 squared, which is 361. 144 plus 196 is 340. And 340 is less than 361. And if it's less than, that means your triangle is an obtuse triangle. Done. All right, if the sum of the squares of two shorter side lengths of a triangle are less than the square of the longest side length, then the triangle is, if the sum of the squares of the two shorter side lengths of a triangle, all right, the two shorter side lengths, let's call them A and B. So the sum of squares, so sum of squares of the two shorter lengths are less than the square of the longest would be your C. Okay. They're saying it's less than, then you would have what type of triangle? You would have an obtuse triangle. All right, you don't even have to do any math. You just have to understand what they're saying. All right, that's all there is to that. Done. All right, in the diagram, XP is 9. PZ is 15. What is the length of YP? Okay. Well, let's see what we have to work with here. Here we have a right triangle, and then they drew the altitude, essentially. All right, so it's going to the hypotenuse. All right, forms a right angle. So we essentially have three similar right triangles here. Okay, so let's work with the smaller one. Then we have, and I'm going to label it too. So it's going to be X, P, Y. Then I have the medium. Okay. So I have Y, P, Z, and I got the whole thing. Which is X, Y, Z. Okay, so let's make sure we label it correctly now. XP is 9. YP is what I'm trying to find. That's all I have there. For the blue triangle, I have PZ is 15. YP, okay, nothing there. All right, then I have the hypotenuse for the red triangle, which is 14. All right, what can we do here? This is what I'm trying to find here. This is what I'm trying to find here. Okay, I could use these two triangles. So I have 9 over YP is equal to YP over 15. Cross multiply. I have YP squared is equal to 9 times 15, which is 135. All right, take the square root of both sides. I have, let's see here, 3 times 15. Sorry, not 3 times 15. 45. 3 times 15. And 3 times 5. All right, I have a pair of 3's. So YP is equal to 3 square root of 15. Done. All right, once again, it's really easy to do these problems when you understand how to apply the idea of similarity and setting up proportions. All right, in the right triangle ABC, altitude CD is drawn to hypotenuse AB. So we'll do this. Hypotenuse AB. All right, we have CD is the altitude drawn. AD is equal to 5. DB is equal to 24. Okay, what is the length of CD? Now, it doesn't matter if the numbers don't necessarily match up with the side lengths the way you drew it. As long as you set up the triangles correctly, you will get the correct result in the end. Okay, what is the length of CD? All right, so I'm going to work with this triangle to start with. All right, I'm going to flip it. So I have, let's make sure to label it correctly. I have 24 here. And I have B, D, C. Then I have this medium triangle here, which is C, D, A. That's 5. Okay. So I end up with, let's see what I have here. This is going to be, this is my right angle. So this is C, that's B, and that's A. CB, don't know. CA, I don't know. I know this is 29 though. Okay. Let's see, I'm trying to figure out CD. All right, so I have CD here. I have CD here. All right, I could set up a proportion. So I have 24 over CD is equal to CD over 5. All right, I cross multiply. CD squared is equal to 120. Take the square root of both sides. I have 2 times 60, 2 times 30, 2 times 15, and 3 times 5. So I have a pair of 2's. So I pull out the 2. What do I have left inside? 30. And that's all there is to it. That's what CD is equal to. Done. All right, in triangle ABC, A is 230, B is 216, C is 194. Find angle A to the nearest degree. All right, so I have A, B, C. Little a is 230. Then I have little b, or lowercase b, is 216. Lowercase c is 194. All right, I need to find angle A. This is my goal. Figure out this angle. Okay, what will we use in this situation? Well, all I know is the sides to this triangle. And when all you know is the sides, what can you apply? You can apply the law of cosines. All right, now I'm going to use the alternative form of the law of cosines. So I'm trying to figure out A. So it's going to be cosine of A is equal to B squared plus C squared minus A squared all over 2BC. All right, so you just have to be careful plugging it in. So I have B squared, which is 216 squared, plus C squared, which is 194 squared, minus A squared, which is 230 squared, all over 2 times B, which is 216, and C, which is 194. Okay. So we have cosine of A, which is equal to, let's simplify this, and we get 31,392 over 83,808. Okay, now how do I get this angle by itself? This is where we use another very useful tool, the inverse trig functions. So I have to take the inverse cosine of both sides. Alrighty, so I get measurement of angle A, which is equal to we will end up getting 68 degrees. All right, as the nearest degree. So the answer is A. Done. All right, in triangle ABC, all right, same situation as number 23. All right, here I have little a is 22.4, little b is 24.8, and little c is 18.6. Alrighty, so find measurement of angle B to the nearest degree. All right, B this time. All right, so this time I'm going to be using the formula, the alternate form of the law of cosines. So it's going to be cosine of angle B is equal to A squared plus C squared minus B squared all over 2AC. All right, just be careful plugging in the numbers. So A, I should have labeled this better. B is that, and C is that. Okay, so we have A, which is 22.4 squared, C, which is 18.6 squared, then we have minus B, which is 24.8 squared, all over 2A, which is 22.4, C, which is 18.6. Alrighty. Trying to find B to the nearest degree. Okay. So working this out, let's see what I get. On the top I have 232.68, and on the bottom I have 833.28. All right, to isolate B now, how do you get it by itself? You have to use your inverse trig ratios. I'm going to take the inverse cosine of both sides. Measuring angle B is equal to Nearest degree is 74 degrees. Done. All right, find the value of x. All right, how are we going to figure out x here? Well, what do I have? I have two similar triangles. They're similar by AA. All right, since they're similar, you could set up a proportion. 4 over x is equal to 12 over 9. I'll show you a different way of setting it up. You could do 4 over 12 is equal to x over 9. All right, it doesn't matter how you go about doing it, you're still going to get the same result as long as they're consistent. All right, so here I have 36 is equal to 12x. Divide by 12, x is equal to 3. That's all there is to it. So if you know what you're doing, you understand the idea of similar triangles and how to set up proportions, you can solve this problem in seconds. On to the next one. All right, here we have two similar triangles. They are similar by AA. So I could set up a proportion. X over 6 is equal to x plus 4, I have to use the whole thing, over 9. Here's another way to do it. I can do x over this whole side here, x plus 4, is equal to 6 over 9. Doesn't matter how you do it, you'll still get the same result. All right, just be consistent with which sides of the triangles you're using. All right, so here I have 9x is equal to 6 times x plus 4. Distribute. I have 9x is equal to 6x plus 24. Subtract 6x. I have 3x is equal to 24. Divide by 3. And x is equal to 8. Done. All right. A triangle with side lengths 6, 13, and 15. I'm going to do something like 6, 13, 15. I'll do this. 6, 13, 15. All right. Is similar to another triangle with longest side length 36. Okay. I'll do something like this. So that's 36. All right. What's the perimeter of the larger triangle? So I'll call this x and I'll call this y. Now, they used the key word in this problem. They said they're similar. So if they're similar, then I could set up a proportion. This is the longest side, 15. This is the longest side to the bigger triangle, 36. So now I take 6 here, and that corresponds to the smallest side here, which is x, and I could solve for x. So cross multiply, or make life easier, simplify this, divide these by 3, and I have 5 over 12. So now I have 5x is equal to 6 times 12, 72. So divide by 5, and x is equal to 72 over 5, which is, how many times does it go in there? It goes in there 14. We get 14.4 from that. All right, I have that to work with. All right, use green now. I'm going to have 15 over 36, once again, is equal to 13 over y. All right, once again, I could simplify this. So I end up with 5 over 12. I'll cross multiply. So 5y is equal to 156. Divide by 5. And y is equal to 31.2. All right, so what's the perimeter? The perimeter is equal to 36 plus 31.2 plus 14.4. So the perimeter is 81.6 units. All right, once again, if you understand the idea of similarity, it's not too difficult. It just takes a little work, You set up your proportions, figure out the missing sides. Done. All right, the sides of a right triangle are 6, 8, and 10. Find the area of a similar triangle whose largest side is 40. All right, so here we have a smaller triangle, 6, 8, 10. Then we have a bigger one. All right, it says find the area of a similar triangle whose largest side is 40. All right, that's 40. We'll call this side X. We'll call this side Y. We have to find its area. Okay, and I want to figure out the area. One thing you have to keep in mind is that this is a Pythagorean triple here. So we're actually working with a right triangle. All right, so that's 6, that's 8, and that's 10. So you don't need to do this here. We're going to set up our right triangles. This will be 40. I don't know what that is. I don't know what that is. But once I figure out X and Y, I could easily figure out the area of the triangle. All right, I could set up a proportion, 10 over 40. 10 is equal to 6 over X. So I have, this simplifies to 1 over 4. So I end up with X is equal to 24. All right, do the same thing for Y. 10 over 40 is equal to 8 over Y. All right, this gives me 1/4. So I have Y is equal to 32. All right, so the area of this bigger triangle is 1/2 base 32 times the height, which is 24. So the area is 384 units squared. Done. All right, the isosceles trapezoid shown has a perimeter of 110 inches. All right, perimeter is 110. A is equal to 109. That's 109 degrees there. And the length of each leg of this trapezoid is 15. Okay, 15 and 15. Find the value of B and find the length of the shorter base. The shorter base. Okay, this would be the shorter base up here. All right, let's see what we're going to do here. All right, well, that's 109. So since it's isosceles trapezoid, these angles are the same. That's 109. And I know that these angles here are the same. Another important fact is that it's a trapezoid. So these two sides here are parallel. All right, that means that these are consecutive interior angles, and they add to 180. So that's going to be 71 degrees. And so is that one. So I already have B. That's done. Now I need to figure out what X is. It says the perimeter is 110. So we need to use this information. So I know 15 plus X minus 10 plus 15 plus X is equal to 110. All right, so I get 2X, and then I have plus 20 is equal to 110. All right, so I subtract 20. 2X is equal to 90. I divide by 2, and I get X is 45. But that's not what they're looking for. They're looking for the shorter base. So I have to plug this in, and I get 45 minus 10, which is 35. All right, so, and I'll just specify that right here, the shorter base, all right, is 35 inches. Done with that. We have the two parts. All right, so for number 30, the isosceles trapezoid shown as a perimeter of 92. All right, B is 63 degrees, and the length of each leg is a trapezoid. It's all right, it's 11. All right, now this is an isosceles trapezoid. Find the value of A and find the length of the longer base. Okay, so if this is 63 degrees here, this is also 63 degrees. And since it's isosceles trapezoid, I know the base angles are congruent. Since it's a trapezoid, I know these lines are parallel, and these angles are consecutive interior. They have to add up to 180. So this angle here will be 180 minus 63, which is 117. All right, so right away, A is 117. Done with that. Then to figure out x, I'm going to use the perimeter. So I have 11 plus x minus 10 plus 11 plus x is equal to 92. All right, so I have this here. I have 2x. Going to combine like terms. I have 22 minus 10, so it's plus 12. 92. I'm going to subtract 12. I have 2x is equal to 80. Divide by 2, x is equal to 40. All right, they're asking for the longest base. So I have to plug 40 back in here, and that's what the longest base is. 40. In this case, centimeters. Done. All right, the perimeter of a trapezoid WXYZ is 200 centimeters. The lengths of the legs WX and WZ are 44 centimeters and 48 centimeters. All right, so I have this trapezoid. This one's 48. This one's 44. All right, what is the, I'm going to call it WX. Z. We're going to have to walk around the figure. What is the length of the median of this trapezoid? Its perimeter is 200. Huh. Very interesting. This is base 1. This is base 2. All right, to figure out the median, the length of the median, or the mid-segment, it's half of base 1 plus base 2, all right? All right, now, you're not going to be able to find base 1 and base 2 individually, but you can find what they add up to. So I know 44 plus 48 plus B1 plus B2, base sub 1, base sub 2 is equal to 200, okay? So here I have 92 plus base sub 1 plus base sub 2 is equal to 200. So I subtract 92. Base sub 1 plus base sub 2 equals 108. All right, I take this and I plug it in to the formula, and I have half of 108, which is 54. And that's the length of my median, or my mid-segment. 54 centimeters. Done. In the diagram, trapezoid ABCD has a median XY drawn. AB is 2x minus 3. CD is 4x minus 1. And XY is 2x plus 5. What is the value of x? All right, using the mid-segment formula, it's equal to half of base 1 plus base 2. So I have the mid-segment, which is 2x plus 5, and that's equal to half of base 1, which is 4x minus 1, plus base 2, which is 2x minus 3. All right, just take your time now doing the algebra. Let's combine like terms here. So I have 6x. Here I have minus 4. All right, so in this case, I'm going to distribute. I have 2x plus 5 is equal to 3x minus 2. And then here I'll subtract 2x. I have 5 is equal to x minus 2. And then here I'll add 2. So x is equal to 7. I found x. I'm done. All right, what convex polygon has an interior angle sum of 720 degrees? Okay, we're talking about the sum of interior angles. What's the formula for that? N minus 2 times 180. And in this problem, they're telling you that it's equal to 720. So we just have to solve for n. I divide by 180. And I get 4, add 2, n is equal to 6. So if I have 6 sides, I'm working with a hexagon. Done. Find the number of sides of a regular polygon with an interior angle measuring 144 degrees. All right, so the formula for finding interior angles is n minus 2 times 180 over n. And that's equal to, in this case, they tell you what each angle is supposed to be, 144. So now I just need to figure out the number of sides, which is n. So I need to get rid of this fraction, multiply by n on both sides. N minus 2 times 180 is equal to 144n. I'm going to distribute. I have 180n minus 360 is equal to 144n. I'll subtract 180n. I have negative 360 is equal to negative 36n. Divide by negative 36. And I have n is equal to 10. That's the number of sides. All right, and that's what they're asking for. Done. And just to get the name down, just like a decade is 10 years, so a 10-sided polygon is a decagon. A regular polygon has an exterior angle of 36 degrees. How many sides does this polygon have? All right, to figure out each exterior angle, I take 360 and I divide by n. In this case, it's equal to 36. So I multiply by n on both sides to start with. Now I divide by 36. And n is equal to 10. And that's all there is to it. That's how many sides I have. Solve for A. All right, here I'm looking at a polygon's exterior angles. I have 5 of them, but it doesn't matter how many angles you have. The exterior angles always add up to what? 360. So I have A plus 95 plus 70 plus 40 plus 82 equals 360. All right, so I have A plus 287 is equal to 360. All right. And A is equal to 73. Done. All right, triangle has 2 sides of length 5 and 14. The third side of this triangle must be shorter than and longer than what? All right. Any 2 sides have to add up to be greater than the third side. So I have 5 plus 14 is greater than x. I have 5 plus x is greater than 14. I have 14 plus x is greater than 5. So x, let's see here, has to be less than 19. But it has to be greater than 9. From here I get a negative number. I'm not working with that. So the third side of this triangle must be shorter than, it has to be shorter than 19. And it has to be longer than 9. Alrighty, that's all there is to it. Alright, Jamie knows the lengths of 2 sides of a triangle are 8 and 12. Use the triangle inequality theorem to determine the possible values for the lengths of the third side of Jamie's triangle. So the third side is x. So we're going to say any 2 sides have to add up to be greater than the third. So 8 plus 12 has to be greater than the third, which is x. Or I could have 8 plus x is greater than 12, or 12 plus x is greater than 8. Alright, so I have 20 is greater than x. I have x is less than 20. Here I subtract 8. X is greater than 4. Here I subtract 12. X is greater than negative 4. Don't need the negative number. So, use the triangle inequality theorem to determine the possible values. Okay, the possible values. So, x is between 4 and 20. All right, this is known as a compound inequality, when you combine two inequalities into one. And the inequalities always point to the left. All right, you start off with the smaller number, you end with the bigger number. Done. In the triangle below, what is the measure of PQ? All right. All right, here is a situation where I will use the law of sines. All right, I have 70, 60. That adds up to 130, so this is 50 here. All right, I have this one side. They want me to figure out PQ. All right, so I'm going to set up a ratio with these two here. I'm going to have sine of 70 over 5 is equal to, I'm trying to figure out PQ, so I'm using the 60-degree angle, is equal to sine of 60 over PQ. All right, this is the law of sines being applied here. All right, so now I cross multiply, and I have PQ times sine of 70 is equal to 5 sine of 60. And I divide by sine of 70. All right, so PQ is equal to what? You don't have to figure it out because it's a multiple choice problem. Everything's left in trig form. Your answer is D. Done. All right, same problem that we did before, but we're looking for QR. So this is 50 degrees here. All right, so I'm going to use this information first because I have an angle on the side opposite to it. So I'm going to have sine of 70 over 5 is equal to, this time I'm looking for QR, so I have to use the 50-degree angle in this case, sine of 50 over QR. Applying the law of sines once again. So I have QR times sine of 70 is equal to 5 times sine of 50. Divided by sine of 70. And QR is equal to, I do not have to figure this out. It's a multiple choice problem. So my answer is B. Done. All right, in the diagram, they tell you that this is a parallelogram, TUVW, and they more specifically tell you that it's a rhombus. So I know all the sides are the same. All right, if VUX, this angle here is 50 degrees, what is the measure of XVW? XVW, this angle here. Okay. Let's figure it out. So this is 50 degrees here. What do you know about a rhombus? Well, we know that the diagonals bisect opposite angles. So if that's 50 here, this is also 50. So this whole thing is 100. All right. Now I know that this is a parallelogram. So these are parallel sides. All right. This is my transversal. These angles here have to add up to 180. All right. So if this whole thing here is 100, then this whole thing here has to be 80. And if the whole thing's 80, well, what's half of it? 40. And that's all there is to it. It's 40 degrees. We're done. All right, but you have to know your properties. If you don't, you're going to be struggling. All right, you have to know your properties from Chapter 3, consecutive interior angles. You have to understand diagonals and opposite angles and be able to identify all those. All right, so you really have to bring all these ideas together, and if you know your properties, you could easily figure out the answer here. All right, find the value of A in the diagram given. B is square root of 14, C is 3 squared root of 2. I just need to figure out A. All right, so I'm going to use the Pythagorean theorem. All right, be careful squaring. So here I have 14. Then I have 9 times 2. So I have A squared is plus 14 is equal to 18. Subtract 14. A squared is equal to 4. Square root both sides. A is equal to 2. Done. All right, find the value of A in the diagram given. All right, same process as before. We're going to have A squared plus square root of 15 squared is equal to C, which is 2 square root of 6 squared. All right, just using the diagram we had before and applying the Pythagorean theorem. So we have A squared plus 15 is equal to 4 times 6. So we have A squared plus 15 is equal to 24. Subtract 15. A squared is equal to 9. Take the square root of both sides, and A is equal to 3. Done. All right, given ABCD is a rhombus, measurement of angle A is 75. Find measurement of angle C. All right, it's a rhombus. All right, A is 75 degrees. They want you to find C. Well, I know opposite angles are the same for a rhombus, or more generally speaking, a parallelogram. So measurement angle C is 75 degrees. That was fast. In the diagram, measure angle B is equal to ADE. How do you know these triangles are similar? I want you to fill it in. All right, so I have A, B, C. That's going to align with A, D, E. And they will be similar by what? Well, the triangles share this angle in common. So it's this triangle and then the whole triangle. So they are similar by AA. Done. All right, in the diagram, measurement angle C is 51 degrees. ADE is 76 degrees. And A is 53 degrees. All right, find two similar triangles and explain why they are similar. All right, it's pretty easy stuff. All right, if that's 53 and that's 76, you subtract both of those from 180 and you get 51. All right, now I have this triangle here and this triangle here. They share this angle in common, and they also share this one angle in common. All right, so they have two pairs of congruent angles. So triangle ADE is similar to triangle ABC by the shortcut AA. All right, that's all there is to it. All right, the midpoint of KL is the point 3, 5. All right, they give you the coordinates for one of the points. What are the coordinates of L? All right, here's the midpoint formula. This is a Y. All right, so I know my midpoint is 3, 5. They give me one of the points. That's my x1, y1. -3 plus x sub 2 over 2. And then y sub 1 is -4 plus y sub 2 over 2. All right, so I have 3 is equal to that. -3 plus x sub 2 over 2 is equal to 3. And then I have 5 is equal to that. I have negative 4 plus y sub 2 over 2 is equal to 5. All right, so I'm going to multiply by 2 on both sides. Add 3. X sub 2 is equal to 9. And I'm going to multiply by 2 on both sides here. All right, so my second point, which is L, will be 9, 14. Well, that's all there is to this. All right, the midpoint RS is the point M for 7. Okay, we're going to use the midpoint formula here again, which is x1 plus x sub 2 over 2, y sub 1 plus y sub 2 over 2. All right, so they give you the midpoint. That's 4, 7, and that's equal to, let's see, applying the midpoint formula. This is my x1, this is my y1. So x1 is negative 2 plus x sub 2 over 2. And I have y1, which is negative 5 plus y sub 2 over 2. All right, so I have 4 is equal to that. So I have negative 2 plus x sub 2 over 2 is equal to 4. And then I also have this equation, negative 5 plus y sub 2 over 2 is equal to 7. All right, let's get rid of the fraction, multiply by 2 on both sides. Add 2. So I have x sub 2 is equal to 10. For the next one, I'll multiply by 2 on both sides. So I have negative 5 plus y sub 2 is equal to 14. Add 5. And I get y sub 2 is equal to 19. So I end up with 10, 19. Done. And that would be point S. All right, solve the right triangle. If A is equal to 11, this would be 11 here, little a, lowercase a. And B is equal to 21, lowercase b. Give lengths to 3 significant figures and angles to the nearest tenth of a degree. All right, don't even get caught up in this 3 significant figures business. All right, it just means use 3 digits to express the length. All right, just use what we're used to working with here, angles to the nearest tenth of a degree. Okay, let's see what we have here. We have to solve the right triangle. All right, I got to find all the missing sides. Well, I'm going to use the Pythagorean theorem. 11 squared plus 21 squared is equal to c squared. So I have 121 plus 441 is equal to c squared. I add those up, and I get 562. Take the square root of both sides, and I get c is equal to 23.7. All right, I got that part now. All right, now how are we going to figure out the missing angles? All right, well, this is relative to angle A here. This is opposite, this is adjacent, this is hypotenuse. You choose which trig ratio you want to use. I'll use sine. So sine of A is equal to opposite, which is 11, over hypotenuse, which is 23.7. All right, well, to get A by itself, I have to get rid of the, to get it by itself, I have to get rid of the sine. So I take the inverse sine of both sides. That's the tool we use when we want to isolate the angle measurement. Okay, so now I have measurement of angle A is equal to 27.6 degrees, rounding it to the nearest tenth. All right, I got that. Now if I want to figure out B, all right, now this will be my opposite, this will be my adjacent, this will be my hypotenuse. You choose which trig ratio you want to use. I'm going to use tangent for this one. Tangent of B is equal to opposite, which is 21, over adjacent, which is 11. So I have to take the inverse tangent of both sides. Alright, so I have measurement of angle B is equal to 62.4 degrees. Alright, I figured out all the missing parts. I have solved the triangle. Done. Solve the right triangle. If B is equal to 6, right, B is equal to 6, and C is equal to 13, alright, gotta find all the missing parts. I'm solving. So I'm going to figure out what lowercase a is. So I have a squared plus 6 squared is equal to 13 squared. So I have a squared plus 36 is equal to 169. Subtract 36. A squared is equal to 133. Alright, take the square root of both sides. I cannot simplify the square root of 133, so a is equal to the square root of 133. Alright, now I want to figure out the angle measurements. So in this case, you could choose whichever trig ratio you want. This is my opposite, this is my adjacent, this is my hypotenuse. I will use cosine. Cosine of A is equal to 6 over 13. So to get A by itself, which tool do you use? You use the inverse trig ratio. So inverse cosine. Alrighty, so measurement of angle A is equal to 62.5 degrees. Done with that. Now I'm going to figure out B. This time I'll use sine. Sine is, and in this case I have opposite, hypotenuse, that's adjacent. So I'm going to have sine of, for B is equal to opposite, which is 6, over hypotenuse, which is 13. Inverse sine both sides. Alright, so measuring angle B is equal to, it's going to be 27.5 degrees. Alright, we have solved the triangle. We figured out all the missing parts. That's it for the review. If you have any questions, make sure to ask. The benchmark is based on all the review questions. So if you understand all the review questions thoroughly, then you should have no problem when taking the actual exam. Alright, make sure you know your formulas. You're not going to be able to use a calculator. You won't be able to use any formula sheets. You have to know your stuff for the benchmark. Once again, ask for help if you need it.